All right, so we're in section 8.3, volumes of pyramids and cones. I can calculate the volume of a pyramid or cone or a specific piece that's in the volume equation. And then we started talking about we have a volume of a solid figure. And if we chop from this point right here in the center and we go to each of the corners, we're literally chopping off 2/3 of our figure. And this is how these three-dimensional pyramids and cones were created, is they put a dot at the top and said, okay, let's shave off some of this stuff. And that's how we come up with this equation of 1/3 times the base area times the height. So originally it was base area times height, and we have a three-dimensional figure, and then we shave off all of the sides and make it come to a point, and then that's what gets us the 1/3 base area times height. So let's look at this example problem. So we have the volume is 1/3 base area times height. Our base shape, we are going to do a rectangle. Our rectangle is our base shape. When we look at the bottom of this, you can see that the green is a rectangle. So how do we find the base area of a rectangle? That's just length times width. And we talked about this before, whether it's 2 times 3 or 3 times 2, we're still going to get 6 either way. So whether W equals 12 or W equals 14 actually isn't going to make much of a difference. But I think normally they call the width the smaller number. So we're going to make the width 12. And we're going to make the length 14. So that our base area, bless you, our base area is going to be 14 times 12, which I don't know what that is. 12 times 14, 168. So 168 is our base area. So this becomes 168 now. Our three-dimensional height. Our three-dimensional height has to form a 90-degree angle and go straight up to the point. And we can see that our three-dimensional height, h, equals 15. So take your volume of 1/3 base area times height and substitute these values into your equation. So this is just a plug and chug. So 1/3, 168, 15. And that's exactly what I'm going to type in. I'm going to do 1 divided by 3 times 168 times 15. And you should get 840. And this will be inches cubed. Still units cubed for volume. If anybody was to have a question, what could a question be? Nothing? We're good? All right, then look at your story problem. The story problem, you measure the height of a pentagonal pyramid. Now, a lot of times you're going to hear things and go, we never learned that, Schmidt. It doesn't matter. We're trying to find what the volume of the pyramid is. So the volume of a pyramid is 1/3 base area times 3D height. So my guess is to determine the area of the base, they're going to give it to you. They tell you the base area. The base area, which is a pentagon, is 110. We don't have to actually calculate that base area. We just trust that it's 110. And the height, so this is the base area. Then they tell us the height is 9 meters. So we have the 3D height, h, to equal 9. And then they're asking for the volume. So the volume equals 1/3 times the base area times the height. So height, base area, substitute it in, and don't do extra work. Like you're working too hard. And you should get 330 meters cubed. Questions, comments, concerns? Where are we at? Make sense? Not make sense? And I struggle because I'm not getting a lot of questions, and we did the area and circumference of the circle, and then we clipped it and did pieces of them. Thought that was pretty straightforward, but I want to make sure there's no disconnect here. Do we understand? Yeah. Yeah. Yes, exactly the way you see it. Yeah, absolutely. Yeah, so when you get this plugged in, just type it in exactly the way you see it. Whether there's pi, squareds, whatever it is, just type it in and get something out. So our next shape, like I told you, we are going to have a cylinder that's doing the same thing. Only we don't have straight edges. I know it looks like a straight edge here, but it's circular all the way around, and the circles get smaller and smaller and smaller until they get to the point. But that doesn't change what we're doing. It's still 1/3 base area times height. And of course, because math always tacks on to old math, when I say volume equals 1/3 base area times 3-dimensional height, what is the area? What's the base area of a circle? It's pi r squared, which is where pi r squared in the equation comes from. The 1/3 is the 1/3. The 3-dimensional height is the 3-dimensional height. And that base area is just the area of a circle. That's how all of it's organized. Still the same type of problem. But remember, the 3-dimensional height, if you look at the picture, this is my base area. The circle is your base area. And then your 3-dimensional height comes from the center of the circle straight up to the point. So when we look at the next one, our 3-dimensional height is turned on its side. And our base area is turned on its side. One-third base area times 3-dimensional height. Our base area is a circle. That is pi r squared. Our diameter equals 8 yards. So how do we find our radius? If our diameter goes all the way across the circle, that's 8. How am I going to find from the center just out to the side? cut it by 2. So I'm going to take this 8 and divide it by 2 to get the radius to be 4. So now I've got pi times 4 squared. That is 16 pi. It's 50.27. So that is my base area. My three-dimensional height h is 9. And then take your volume formula. And plug in your values. So my base area is 50.27. My three-dimensional height, h, equals 9. And then 1/3 is 1/3. Type it in exactly the way you see it. 1 divided by 3 times 50.27, right? 50.27 times 9. And you should get 150.81. And this is yards cubed. So volume is always in units cubed. Now for the last part, they're going to give you the volume. Now we need to calculate something. So whatever it is, especially in this unit, do 1/3 BA times H. You're either going to be looking for the base area, the height, or the volume. Maybe they might ask you something inside of a base area, but be careful with that. Just pay attention and see what the question's asking you. So, given the volume of a triangular pyramid is 96. So the volume of a triangular pyramid equals 96 kilometers cubed. The height, so the 3D height, h equals 12 kilometers. So units match up, so I don't have to worry about that. Volume equals 1/3 BA times H. My volume is 96. My BA is BA times by 12. And they're just looking for, the question is asking us, what is the base area of my pyramid? So I am looking for BA. So the first thing I can do is 12 times 1/3. So I'm going to do 1/3 times 12 and get 4. So then this becomes 96 equals 4 times BA. Well, if it's 4 times, how do I get rid of times? Divide. So divide both sides by 4. And you have your base area answer with whatever that is. And our base area is going to be 24, and then put kilometers squared, because area is measured in units squared. It's a T formula sheet. So when we look at the formula sheet for the SAT, That's a good one. So here is the 2 formula sheets I gave you, but this is going to be your focus. And I'm going to put this on a Google Doc and print it off so that, oh, that is not, is it? Is that the exact sheet?
Yeah.
Okay, so they do give you that. Interesting. And they give you the thing at the end. Cool. All right. So that's your formula sheet. And you're given that on the SAT. You can use that at any time. So you have these volume formulas right at your fingertips.